Hey guys, welcome once again to Physics Classroom. I'm still your tutor, Engineer Newton, and today I'll be taking you through the topic I term simple AC circuit. What does that term AC stand for? AC stands for alternating current. So it will be best for me to say we are going to be considering the topic simple alternating current circuit. First and foremost, let's start by defining alternating current. What is an alternating current? An alternating current is the one in which the current changes periodically. That is, with periodic frequency. It changes with periodic frequency. And the symbol that represents alternating current is this. We can as well refer to this symbol as an alternator. An alternator. Please take note. Then, when we come to think of alternating current, something must come to mind, which is alternating voltage. Alternating current brings about alternating voltage. And how then do we define alternating voltage? Alternating voltage is the EMF, that is electromotive force. It is the electromotive force which gives rise to alternating current. That is, alternating voltage brings about alternating current. The simplest representation of alternating voltage or current is one in which it varies as a sine function of time. What am I saying here? Alternating voltage is equal to the peak voltage sine of omega t, where your omega here represents the angular velocity and t represents the oscillating time. In terms of the current, we can say it's equal to peak current sine omega t as well. And we know that omega, which is angular velocity, is equal to 2 pi f. 2 pi times the frequency, oscillating frequency. So this can change to maximum value of voltage, which is peak voltage, sine 2 pi ft. As well as this, that of the current will change to maximum value of current or peak current, sine 2 pi ft. Where V naught is equal to maximum value of voltage. I naught is equal to maximum value of current. You see, this V here can be said to be effective voltage or root mean square voltage. Likewise, this I could either be effective current or root mean square current. So you can have it like this. V RMS is equal to root mean square voltage, while I RMS is equal to root mean square current. What else? Omega. In this regard, it connotes angular velocity. Angular velocity, of course, is measured in rad per second. Then the T represents oscillating time, while the F represents oscillating frequency. Please take note of all this. They are very, very important. That brings us to effective or root mean square value of current and voltage. Effective or root mean square value of current or voltage. We are going to be taking them one by one. The first one, effective or root mean square value of voltage, that is VRMS, and is given by the equation peak voltage or maximum value of voltage all over root 2. Take note of this. That is for the effective or root mean square value of voltage, which is equal to V naught all over root 2, which can also be presented as 0.707 V naught. What have I done to that regard? What I did is simple. It means 1 all over root 2 times V naught. So if we say 1 divided by root of 2 is going to give us 0.7071, which I approximate to 0.707. I believe that is clear. Then we'll move to the next one, which is the effective or root mean square value of current, IRMS, which will be equal to the peak value of current or maximum value of current divided by root 2, which can also be rewritten as 0.707 I naught. So I want us to pick just a question from this area before we move forward. Let's take the first question, which says the peak voltage of a 110 volt root mean square main supply is. They are asking you to calculate the peak voltage. So the way to approach this question is simple. The first thing is to recall that VRMS is equal to peak voltage all over root 2. And according to the question, you are being given the root mean square voltage to have the value of 110 volts. And you are expected to determine the value of the peak voltage. So what you will do here is to make V naught the subject of the formula, which will be V naught is equal to VRMS root 2. And that is it, which will be 110 root 2. And that will give you approximately 156 volts to be your V naught. As simple as that. Now, let's move to the simple AC circuit proper. For us to consider simple AC circuit, 3 components must come to mind: the resistor, capacitor, and inductor. We represent resistor with the symbol R, inductor with the symbol L, capacitor with the symbol C. When we speak of resistor, the next thing that comes to our mind will be resistance, which is measured in ohms. Resistance of a resistor is measured in ohm. Inductance of an inductor is measured in Henry, while the capacitance of a capacitor is measured in farad. That's the first thing you need to know. That's the first thing you need to know. Resistance is resistor is having resistance. Resistor is having resistance. Inductor is not having resistance. Neither is capacitor having resistance. So we are going to consider something that will act in place of a resistance. And that's what we call the reactance. Reactance. So this reactance is symbolized by the symbol X. It serves as a resistance in inductor or capacitor. What then is reactance X? Reactance X is the resistance in an AC circuit by either capacitor or an inductor. The resistance in an AC circuit by either what? A capacitor or an inductor. So if we are dealing with inductor, for instance, we'll be having what we call inductive reactance. Inductive reactance, and that is XL. But in case of capacitor, we call it capacitive reactance. Please take note of all this. Take note of all this. They are very important. For the inductive reactance, it's usually calculated using this formula omega L. I told you earlier that omega is equal to 2 pi f. So this will become 2 pi F times inductance of an inductor. While for capacitive reactance, is calculated using the formula 1 all over omega C, which is 1 all over 2 pi F times capacitance of the capacitor. Take note of that. That is, if we are working on inductor, we use the inductive reactance in place of resistance. Then when working on capacitor, we use capacitive reactance in place of resistance. Hope you understand. I will explain, I will shed more light later on as we move. Now, what if we are now combining the inductor or capacitor with maybe resistor or with themselves? That brings about something else different from reactance, which will also serve as opposition to the flow of current. And that's what we call the impedance. 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 And the symbol for impedance is Z. Impedance. Impedance. How do you define impedance? Impedance is the effective opposition by 2 or 3 of the components like resistor, capacitor, inductor in an AC circuit. The effective opposition to the flow of current in an AC circuit is impedance. We use the term effective because it has to do with combination of 2 or 3. Is it that when we combine R and L, we'll be having impedance in that case, or R and C, there is impedance, or L and C, another impedance, or when we combine the 3, RLC, there will be impedance. So it's kind of, let's say, the total opposition to the flow of current in an AC circuit. When 2 of those components, 2 or 3 of those components, RLC, are combined together. I believe that is clear now. So we'll move to the next aspect.